welcome back. We're back. We'll be back. Soon you'll see. Here we are. Here's our lesson. Today's lesson is on how to convert decimals that repeat into fractions. We'll start with what we know, transition into something maybe we don't know, and then we'll head over there and see what's going on over there. Okay, 0.25. Let's start with that. What is the fraction for 0.25? Duh, you know what it is. It's 1/4. It's 25 over 100. Okay, so we can easily just set that up and say this is 25 hundredths because it terminates. There's no repetition there. We'll repeat 0, 0, 0. But it is 25 over 100. Okay, and then you can simplify that. Divide them both by 25. So 25 divided by 25 and 100 divided by 25. And you got 1/4. It'd be really nice if that was the end of the video, but it's not. So now we're going to come over here and talk about what if it repeats single digits. Okay, so 0.3 repeating. Well, in order to prove to you that it is 1/3, because I could just say equals 1/3, and you can take my word for it because teacher says, or we could actually go through a mathematical proof to do so. Okay, so the first thing that we do in this proof is we have to make it into an equation. And then via transitive property, substitution, I will show to you that if n equals a decimal and n equals a fraction, that the decimal equals the fraction. Okay? We'll state that again when we get done with the proof. All right, here's what I want you to do. In order to get through this, I want you to multiply by this place of repetition. See how it's just 3, 3, 3, 3, 3 forever? You don't see it? Okay. Dot, 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 with 3 dots. Since there's only one digit that repeats, that's in the tens place. Multiply both sides of this equation by 10. Okay, so we have 10 times n, and we have 10 times this decimal, which shifts the decimal 1 to the right. Right there. So we now have 3.3333 dot, dot, dot. Okay. Now, the whole key to this is I have to cancel out the repeating decimal. Now, the way to do that is to subtract the same thing from itself. So I'm going to subtract the value of n over here, minus n. And then on that side, I'm going to subtract 0.3333. Because isn't n equal to 0.3 repeating? Yes, it is. We stated that back there. So when you subtract this from both sides of the equation, you're subtracting the same thing, essentially. This cancels. 0.3 repeating minus 0.3 repeating is 0. But then we also have 3 minus 0 right here. Okay? So draw like an old school subtraction line. 3 minus 0 is 3. 10n minus 1n is 9n. Okay, now that's a one-step equation with no repeating decimal. So let's solve the one-step equation. Divide both sides by 9. Divide by 9. Looks like n equals 3/9. Oh wait, well we could simplify that. Divide them both by 3. Numerator, denominator. So divide by 3, divide by 3. It appears that n is equal to 1/3. I'm going to write that real big right here. n equals 1/3. Oh, but wait, there's more. If n equals 0.3 repeating, back at the beginning, which it did, and n equals 1/3, if n is equal to two separate things, they have to be equal to each other. That's called the transitive property. That's how that works. Okay. So I'm going to say that 1/3 equals 0.3 repeating. Because it's true. Because they both equal n. Okay. Oh yeah, we're going to go over there. And we're going to do some more baseball. Because, you know, it's fun. Time. Hey, what are you doing? No, you can't sub people in. Let's get this last one done. All right, so we got 0.36 repeating. If you remember the steps from before, we're going to set it equal to n first. That's step 1. N equals. Step 2, multiply by the last digit of repetition. So in this case, we go 0.363636. The 6 is in the hundredths place. That's the last digit until it repeats again. So we're going to multiply both sides by 100 because now we have an equation that we're going to solve. So times 100, that would be 100 times n, which is just 100n. Over here, when you multiply by 100, that moves the decimal 2 to the right. So we've got 1, 2. So you're now at 36 points. But what follows? Well, this is 3, 6 repeating, so it just continues. 3, 6, 3, 6, 3, 6. I think I would like you to write down at least 6 digits of the repetition and then a dot, dot, dot. Okay? All right, step 3. Sorry, that was step 2. Step 3. Subtract by the value of n if it's all digits repeat. Okay, so in this case, you're just going to subtract 1n. Remember, this is 1n equals. And you're going to subtract 0.36 repeating. Again, add a couple of 3 6s on there. So you have something to cancel. Draw an old school subtraction line like that. And this cancels. 3 6 repeating subtracted from itself is 0. And then 36 minus 0 is just 36. Okay, so over here we have 36. Bring down your equal sign. Over there, it's 100 minus 1, which is 99, n. All right, 100n minus 1n, my bad. Step 4, we're going to divide both sides by 99, which is the coefficient of n. That's how you cancel that. Cancellation. And looks like we have n equals 36 over 99, which of course can be simplified. So we're going to divide both of those by 9, which is 4/11ths. So it appears that 0.36 repeating is actually 4/11ths as a fraction. So that fraction has a decimal expansion of 0.36 repeating. Repeating decimals are rational because they turn out to be fractions. There you go. We're doing that again. Marker toss. 1. Have a good day.
Hey, now that you've watched that wicked awesome video, you should probably go to my website and complete these activities that you're supposed to do for today. Number 1 is the Desmos on converting repeating decimals to fractions, which follows the video. Number 2 is a Kahoot. It's optional, but why not? And number 3 is an IXL on comparing rationals. All you're going to do there is see which is greater than the other. Maybe they're equal to, and you'll just have to decide between those. So remember, we're looking for quality, not quantity, so please do the best you can with each one. Let's see, 1/5 is greater than -1/2. It's really that simple. Just make good decisions, okay? Fun. As long as you've done 10 minutes and completed this and watched your video and taken your notes, you're good for today. All right, I'll see you guys tomorrow on the Zoom at 10 o'clock.